In this video, we're going to be factoring trigonometric expressions. Now, when factoring trig expressions, it's helpful to find a polynomial form that fits the expression. So we're going to go ahead and we'll start by factoring the secant squared of theta minus 1. Now, we're going to start off by saying we want to let u equal the secant of theta. So u is going to be the secant of theta. So what does that mean that we have? Well, we can take this piece here and we can replace it with our secant squared. Or with our secant rather. So we're going to place in here our u. But it's not just a u, because remember u is just one of the secants, right? U is just one of the secants. And it's supposed to be squared. So what we really end up having here is u squared minus 1. Let's do that in blue so we can kind of follow it. Now this, here we have a difference of squares because u squared is a perfect square and 1 is a perfect square. And we have a subtraction between the two. So we are able to take the square root of both of those, and that then becomes u plus 1 and u minus 1. Now that I have it factored, now I want to go ahead and plug back in what I got, or what our u meant. So remember, our u is the secant of theta. So this is going to become the secant of theta plus 1 and the secant of theta minus 1. And we're finished. So when it talks about finding a polynomial form that fits the expression, what it's referring to is this u squared minus 1, where we were able to find the difference of squares there. Because that's a polynomial form that we're comfortable with. Or at least more comfortable with. Let's take a look at our next example. Here we have 4 times the tangent squared of theta plus the tangent of theta minus 3. So in this case, we want to let u equal the tangent of theta. So we're tangents of theta and replace them. So we want to take each of our tangents and replace them with the u. So this will give us a 4, or rather, let me use a different color. That's going to give me a 4 u squared plus u minus 3. And this is something that we feel a little bit more comfortable in factoring. So I'm going to use this disco box, because that's kind of a fun thing to call it. So to do the disco box, we take the first thing and we're going to put it in the first box, so 4u squared. And we're going to take the last thing and put it in the last box. Then, I think I'm going to switch up my colors really quick. All right, there we go. So then I'm going to multiply the 4 and the negative 3, because I already know that those are going to have u's in them. So that gives me a negative 12. And from here, I want to break that apart and go, what two numbers will multiply to negative 12 but add to a positive 1? And in this particular instance, 4 and negative 3 fits that bill pretty well. So I'm going to go ahead and plug in a 4 and that negative 3 into my leftover pieces. And then look to see what they have in common. So this first row has a 4 and a u in common. The second row has a negative 3 in common. Our first column has a u in common, and our second column doesn't really have anything in common, so we've got a plus 1. Then we're going to take these pieces right here, and those are going to become our factors. Oops, that should be a minus 3. Let's try that again. And I'm going to replace the u's with blue u so we can see it move. So from here, now we need to simply take our u's and replace them with our tangent of theta. And so what's that going to give us? is it's going to give us the tangent of theta plus 1 times 4 times the tangent of theta minus 3. And that is our polynomial, that is our trig expression factored. And we're finished there. Now, on occasion, factoring or simplifying can best be done by first rewriting the expression in terms of just one trig function or in terms of sine or cosine alone. So take a look at this first example here. Here we have the cosecant squared of x minus the cotangent of x minus 3. So what do we know? Well, we know that the cosecant squared of x equals 1 plus the cotangent squared of x from our trig identities. So here, we want to let u equal our cotangent of x. So u is going to equal the cotangent of x. So what do we have? So we're going to replace our, let's do this, our cosecant with our 1 plus the cotangent squared of x. So I'll put that into that place, 1 plus the cotangent squared of x. So I'm plugging that in, minus the cotangent of x minus 3. So now if we're going to let u equal cotangent, then what we have is a lot simpler. Now, because we're not multiplying anything, what we really have is we have the cotangent squared of x minus the cotangent of x, and then we're going to take our 1 minus 3, let's do that in a different color, our 1 minus 3, and that's going to give us a minus 2 right there. And now we're going to take this and let u equal that cotangent that we were talking about. So in this situation, I'm going to be replacing it here and here. So I'm going to have u squared minus u minus 2. Let's go ahead and let's make those blue. So u. So now we want to know, how do we factor? So here we're looking for two numbers that will multiply to -2, but add to this -1 right here, right? We want it to add to the -1. So if we take a look at this, you might remember this hint from your Algebra 1 days. Because this sign is minus, that means my symbols were going to be different. And because this symbol is a minus, that tells me that my bigger number is going to be the -1. So in this situation, what we're looking at is the only numbers that will multiply to 2 are 1 and 2. So I want my bigger number to be negative, but I need them to be different. So that means my 1 needs to be a positive. So when I add these together, I get the -1 that I need. So let's continue on with factoring this. So if we continue with factoring this, we now have our u's, and we're going to have a +1, and we're going to have a -2. And now we just need to plug back in the fact that our u's are really cotangents. So we plug it in, and so now we've got the cotangent of x +1 times the cotangent of x -2. And we're all factored and finished. Take a look at letter B. Here we have the sine of t plus the cotangent of t times the cosine of t. So in this particular case, we're going to rewrite our cotangent in terms of sine and cosine. Because recall, keep that green, that cotangent of t is really the cosine of t divided by the sine of t. So what we have is the sine of t plus our cosine of t divided by our sine of t times the cosine of t. So what does that give us? Well, that now gives us the sine of t plus the cosine squared of t divided by the sine of t. Remember, that's cosine over 1, and a cosine times a cosine is cosine squared. Well, when we add this as fractions, we need common denominators. So we're going to multiply this by the sine of t on the numerator and the denominator, and that's going to give me the sine squared of t over sine of t plus the cosine squared of t over the sine of t, and I can put those together. So when I put these together, what that's going to give me is the sine squared of t plus the cosine squared of t over the sine squared of t. And from our Pythagorean identities, we know that sine squared of t plus cosine squared of t equals 1. Let's go ahead and let's write that down. I'm going to scoot this over a little bit so we have some room. So we know from the Pythagorean identity that the sine squared of t plus the cosine squared of t equals a 1. And so here we're allowed to say that this is a 1 over the sine squared of t, which is actually, or actually that should be the sine squared of t, because a sine plus a sine is still just a sine. There we go. A sine of t. There we go. And 1 divided by the sine of t is the reciprocal identity for the cosecant of t. And that is going to be our answer.